Greetings, everyone. This is Eric Andelin, Senior Workflow Specialist with SimActive, and you're joining us for the webinar, How to Save Time and Money on Your Photogrammetry Projects. And with me, I have my guest, Michael O'Sullivan with SimActive as well. Michael, say hi to everybody.
Hi, everyone. Hi, Eric. Thank you.
Great. Good to see you. Michael, give everybody a little bit of your background and what your role is at SimActive.
Sure, absolutely. So, hi, everyone. My name is Michael O'Sullivan. I'm the VP of Sales here at SimActive. I've been with SimActive for close to 6 years now, and been in the industry, the mapping industry, for a little bit more than 10 years now. Went on the drone manufacturer side, and then came back to software after a bit. So I've seen both hardware and software over the years, basically.
Very good. Yeah, so like you said, you've been in the industry for a while, myself as well. And, sometimes I have our technical support guys, David and Thomas, on, and they have a unique perspective on, how our customers are doing, what issues they have. You also have a unique perspective from a different angle. So that's why I thought it would be great to have you on to talk about some of this stuff, because it's not necessarily the technical side in this case. It's just more about, what are our customers looking for? What is going on out there in the industry, and how does Correlator 3D help our folks out? So before we get too deep into it, the topics that we're going to cover: common challenges and impacts on cost variations as project sizes increase, then workflows in Correlator 3D that we designed to help minimize man hours, and then accelerating timelines with distributed processing. Looking at some of the common challenges and impacts on cost, what are your thoughts there? What do you hear from the people that we're working with?
For sure. Yeah. As you said, Eric, I oversee a lot of the accounts and the operations that are happening worldwide. I work a lot as well with David and Thomas. So I'm very aware of the challenges, both technical and also just from a pure budget perspective that our customers are encountering. So I think a lot comes down to, planning, obviously, a project, how you're going to approach it. I think we're going to go a bit into that, but mobilization, all the time that it takes to plan your flight, all the time it takes to perhaps put control, place the control, measure it, all of that, and how you're going to potentially divide a project or not. So there's a lot of variables that come into play, and I would say these variables actually have a significant impact on the bottom line, ultimately, of a company's project, and how efficient they're going to be, and ultimately on the margin they're gonna make on that project.
Yeah.
So it's very significant. Yes.
So some of the things, they're out of our control. That's not something that's part of what we can do at SimActive to help them out, but they're also common across platforms or sensors, and project planning, survey control, those type of things. They have a fixed dollar amount per hour tied to, say, an employee or a survey crew or something like that. Just like everything else, those costs go up. So we have to be conscious of that, but that's not something that's necessarily in our control. So, depending on the aircraft you have, whether it's a drone or an aircraft, whether it's a multi-rotor, whether it's, a fixed wing drone, those all are decisions that, that people make ahead of time before, they go down the road with us. But, to that point, what are your thoughts on, do you see the drone industry moving from multi-rotors more towards fixed wings, or is it the same? Has nothing changed? Are we still seeing, that? To me, I would think that, people are probably capturing larger areas with fixed wings.
Yep. Yeah, absolutely, absolutely. I think we do see over the past few years the switch or the progression towards fixed wing. It's like more, it's easier to fly. It's easier to set up these missions. It's easier to accomplish them. It's easier to cover more ground. I think there's still obviously a bit of a, especially in the US and North America, a bit of a limitation with, the regulations, obviously, like
Mhm.
flight height, typically 400 feet, visual line of sight. And so that kind of dictates how you should, run your project. But definitely, we see significant progress being made towards flying rather large data sets with fixed wing. But sometimes and I'm sure you can attest to that, Eric, as well, but sometimes the limit, the threshold is hard to gauge. Even sometimes we see certain customers flying projects with multi-rotors that perhaps should have been a fixed wing project, and fixed wing drone projects that perhaps should have been airplane projects, and vice versa. So I think this is also interesting, like where, I mean, which tool is the best to ultimately make the most profit, right? So,
Yeah. And I feel like especially when companies are using drones, maybe they started out as a survey company and they wanted to pick up some additional ability to capture larger areas than just a field survey. But that does not necessarily mean that they want to get involved in aerial photography with an aircraft. So maybe a drone is as far as they want to go. And you can capture large amounts of data with drones. As long as you've got the time to do it, you're just going to have massively huge data sets, which are great. We love them, and we're more than happy to
sure.
help our folks process them. But yeah, I mean, in reality, the bigger the project, especially with drones, the more missions that you have to fly, which goes to your point that you're probably not seeing as many multi-rotors, doing large mapping projects just because it takes forever and you're going to have a whole bunch of missions. But we do have now established fixed wing drones. We have Quantum and Wingtra and maybe Sense flies out there. I don't know.
Yes.
But what are your thoughts on these larger drones and their ability to capture larger areas?
I think, quite frankly, they can be well suited for it. Having even myself, seen both the Quantum, the Wingtra in action many, many times over the years, it's a fairly easy process, accessible to everyone. The data collection is rather streamlined, but surely, as you mentioned, I mean, it collects a lot of data, right? So the challenges, I think, come more on the data side ultimately, and what to do with all this data and how to process it effectively. But from a collection standpoint, I think it's honestly very doable, provided that you have access to, of course, launch spots and recovery spots that are suited for these types of drones, right? So I think that's something to consider as well.
Yeah, that definitely. Yeah, I'll got to say the one thing I always think of is with fixed wing drones, there's just way less of a pucker factor when you're flying them because
Sure.
it's still technically an airplane. It'll still glide down, whereas if you're carrying a big payload in a multi-rotor, you're just always fingers crossed till it comes down and lands. So I think
For sure.
that plays into it as well. Um,
For sure.
yeah,
Trust me, I've done my fair share of demos with drones, like coming in hot and then landing, and you need a lot of space. So obviously there's something that can be said here as well with, the VTOL, right? The vertical takeoff and landing fixed wing drones like Quantum and Wingtra that are honestly well suited to, for more restrained areas where you perhaps don't have as much space to operate. So, but done my fair share of drone demos over the years, that's for sure.
yeah, and honestly, people maybe don't consider that, and maybe they do. That's why we don't see SenseFly as much anymore. But The
Yeah,
VTOL fixed wings, you know, they're fantastic. They require a very small footprint, like a multi-rotor, to take off. And you know, I've launched VTOLs, you know, right off the side of the highway, you know, and things like that. And you're right. You're confident they're going to come back. They're going to come back and land where they're supposed to. So that makes it a lot easier than the old days of, you know, throwing a precision hawk up in the air and then waiting for it to
sure,
land and drag across the, you know, the pasture that you're near. So yeah,
sure.
that's definitely one thing. But I would think the trend is that we're seeing our customers and potential customers, you know, capturing much larger data sets, and that's a concern of theirs. Is this correct in your opinion?
For sure, absolutely. I think we've definitely seen, over the past few years, perhaps over the last decade, projects going from thousands of images to tens of thousands or hundreds of thousands of images. It's really not uncommon to hear someone trying to process, 50,000 images up to 100,000 images. So
Yep.
there's definitely, democratization of the drone. The drone being used in many types of projects, and we see more and more volumes of data sets being collected. That's for sure.
And
Yeah,
and also to that, higher resolution cameras. So now we're not talking
yeah,
about 20 megapixel cameras. We're talking about 60 and 150 megapixel cameras, which are just real. I mean, they're massive data sets.
yeah, most definitely. So perhaps there's something that can be said as well, that with larger footprints or cameras, you cover ultimately less images. But you're right. Ultimately, it's still like larger images, obviously, that need to be handled by the software.
Yep.
So, for example, and I think you're aware of it as well, Eric, but both, I think we mentioned them like a few times, but both the VTOL manufacturers, Wingtrak, Quantum, they released, the Sony 61 megapixel. So we see that sensor more and more over the past few months, and yeah, exactly.
Yeah.
Yeah.
Oh, yeah. So we should probably talk a little bit about you know, cost variations as project size increases. I mean, just in general, a typical project can be broken down into basically 8 steps, or 8 items, and that's flight planning, mobilization, missions, project setup. Then there's the processing itself, the editing, QA/QC, and then output to deliverables, so that you can take it into your preferred software and create those final products for your customer. Out of that, though, we can look at who would be doing those. So flight planning, you're probably going to have that licensed surveyor or a photogrammetrist, somebody like that, who's a responsible person in charge. They're the ones responsible for the project. The mobilization and flying is usually done, that's basically a 2-man crew. Now, if you're a survey company, that's probably a survey crew, and you probably bill them out at the same rate as a survey crew. A few years ago, when I was involved, it was probably around $200 an hour for a 2-man crew. I'm sure it's more than that now. Then the project setup is probably done by a senior person within the organization, and then the processing itself, I mean, that's software that does that, but it also involves being monitored, and there are activities to that, which would be just a technician. The editing, again, would be a technician, maybe it's tiling or whatever. And then there's a QA/QC component that would, again, fall back on the professional. Outputting the deliverables would go back to the technician. And the reason I bring these up is there's 3 different rates of pay for these type of people. So if, for example, maybe you're professional, your licensed surveyor, it could be anywhere between $175 and $250 an hour. Your 2-man crews, probably $225 an hour, something like that. And your technician, that's somebody earlier on in their career, and they're probably billing out at maybe $80 an hour or something like that. But some of that, obviously, we don't control. Yeah. Once you start project setup, that's where you start looking at your software and saying, how do I do this within the software that I'm using? And how's my processing going to go in all of that stuff. And the reason I bring that up is because we'll show some graphs here later on that show, basically comparisons in cost and comparison in man hours and hours to get things done. But these are all cost variations that we need to consider. If you can complete a project as a whole project, you're spending a lot less time processing. Every time you have to break a project up into subsets, those subsets have to have overlap because you're going to put them back together. And so every time you break something up into a subset, you're probably adding 10 to 25% additional work to a project. What are your thoughts on that and how we look at that on our end?
Right. I think it's a very good point indeed. So as you mentioned, the bigger the project, the more we notice our customers using various solutions out there have to break up the project. Typically, you have to keep some overlap as well, right, between those projects that you divide. And sometimes you also have to add control, in these sections. So you can imagine this adds time in the field. This adds time also on the data processing side, having to restitch, like segments and blocks together. Well, our approach to this is, to have essentially a robust software, right? A robust enough software to be able to handle very large amounts of data in one shot. And this is one of the big, advantages that we have to offer to our user base. So, yeah.
Yeah, that's so. I agree. It's to anybody's benefit to be able to process it in one shot, and then go from there. Now, that's not always the case. Sometimes, it's desirable to break it up, but you just have to be aware of that when you're doing this project setup. So that's a cost variation that needs to be considered. Now, to do this, you have to think about where are you going to process? Are you going to process locally? Are you going to process over a network? Are you going to try to process over the cloud? Describe, for the folks watching or listening in, what is the philosophy again with SimActive on, what you need to process data?
Right. So mostly, I would say the vast majority of our users process locally, and we see added benefits to processing locally. I can give you a small example, but just the fact, depending on the project size, but just the fact that you can process on your laptop an initial stage, in the field, having sort of a validation stamp on the data that you just collected is a potential huge gain that you can have with SimActive, so that you can have essentially a validation of what you just flew and not having to wait until you come back to the office and checking it and checking everything and then potentially having to refly the mission. Mm-hmm. And then the second, so SimActive can be used on, both local or cloud instance, or, whether it's Azure, AWS, or whatnot. But I would say what we notice quite often is that there can be a bottleneck as well on the upload and download that happens when our customers are using a cloud setup, which can be, quite frankly, like sometimes limiting in that aspect. So what we see our customers having the most success with is a fairly simple, like, local setup, where they transfer the data locally. They launch the processing right away locally on, using all the SimActive technology and, GPU power, like base DSM generation and all that good stuff, and get faster turnarounds than if they were to use a cloud setup per se. So we're very much fond and encouraging, because we see the success our customers are having with a local setup for our customers, for our users. Yeah.
And these aren't super powerful workstations. They're pretty run of the mill.
Correct. Good processing PCs, I would say, but nothing out of the ordinary. Sometimes we do hear people buying these kind of supercomputers with 256 gigs of RAMs. but it's not like that with SimActive. That's a fairly complete machine with 32 gigs, with a good GPU, with an SSD, will bring you plenty of processing power to process, honestly, like very large data sets already. So it's due to the software architecture mostly, and yeah, it's very efficient.
And one thing you mentioned, and I wanted to bring up because I do hear this from our technicians, David and Thomas, a lot, is that SSD is, if you're looking for gains in processing speed, that SSD really helps.
Yes, definitely. It's, I mean, all the reading and writing, right? So it's a lot, obviously photogrammetry is a lot of reading images, a lot of writing images when you do the orthorectification process. So, I mean, an SSD will undoubtedly, benefit that process and accelerate that process. So yeah, Thomas and David are definitely right on that topic. Yeah.
Another thing they've told me they've run across a few times is the customer will call and say, hey, I'm looking at the performance stats in Windows, and it's telling me I'm not using my GPU at all. And the answer to that is it's using your GPU as efficiently as possible. So it's not cramming stuff in and waiting for it to squeeze through that little funnel of a bus. It's efficiently pushing those through. And that's why we have the gains that we have when it comes to processing those large data sets.
Absolutely. Yeah. And on the opposite, I would bring the point that any software that overloads any component to 100% is typically a badly designed software. So, yeah.
Absolutely. So, I'll put up a slide, and I just want people to see this. This is a project in Selma, Alabama, that one of our customers was working on. This is roughly 9,000 images. I was able to process this locally, no problem, one batch. And what you can see here is that even though I could process it that way, and it's not that big a data set to us in the world of SimActive, this was flown over like 6 or 7 missions. So, and I believe with Wing Trust. So they went out and flew this, and that's on them, that's their time. But just as an example, so people could see what it would look like. And then, the comments again about processing in subsets, even if you were working with a software where you had to process in subsets, how do you break it up? I mean, you can look at it and say, do I create a tile scheme with X amount of overlap, and I sort out all those images into a folder, and then I process that data set, and I do this 10 times. I mean, how much work is that when you're talking about a human touching it? That's technician work. Those are hours. That's not just saying, processing workstation go. So keep that in mind when you're considering, a software for this type of work. And then again, even after you do all that, you're going to have to merge those data sets together, as we talked earlier. And anytime you add man hours to a project, that's gonna create costs. It's gonna create more processing hours, and it's gonna it may affect your margins on your project because you have to be competitive in this market. Workflows in correlated 3 to minimize man hours. Let's talk about that. And I mean, you and I could talk about this for fun. So, but we should talk about what we can do there. We've talked about an unlimited number of input images. So how do we minimize the manned effort when we talk about using correlated 3? So, your thoughts on how we do that?
Yeah, definitely. I mean, so inherently it comes from the ability to process large data sets, like you say, the robustness of the software. I think, in my point of view, and what I like to say the most is that Correlator 3D is a production software. Really, it stands out as a production tool. We have streamlined processes, scripting. You can create projects and entirely automatically and script, the processing in whichever way you want within Correlator 3D. So that in itself, you can imagine, limits a lot the man hours having to go from one section to another or one phase of the photogrammetry process to another. I think also, to some degree, it limits the potential for error. As you say, not having to, divide a project into sub projects like is a huge advantage. Sorry, because it limits, the infiltration of errors, even the naming patterns of the images, for example, or the way you set up or overwrite specific folders. All I'm trying to say is that there's a lot that can go wrong, basically. And so with SimActive, we really push aside all these hurdles. I think it's quite known already, but we come from the large format, type of processing. So, manned aircrafts, metric cameras, very large data sets, very, very large images. So that ability to handle, large images, large footprints, large data sets is native to the software almost. And it's something our developers always focus on. So almost every year we have new versions that are specifically targeting speed, gain of speed, gain of productivity. And I would say this is really the number one reason why our customers appreciate us. It's in the game of speed, reducing the bottom line, making things more effective. Very proven that time is money, and that the more you save time, the more you save money, obviously. So
yeah.
Yeah.
Interestingly, you mentioned this. We did come from the aerial and the satellite world, so we're used to processing large data sets, especially from large sensors. So sometimes our people working in the drone world don't realize that it's actually easier to process larger data sets from large format aircraft because there's fewer images. For example, those 8,000 images I showed earlier in that slide, I could probably be done in about 50 images from a large format aircraft. So there's a lot less AT to do. There's the process is even faster. So you have to consider that. And again, it's your cost and what your customer is willing to pay for the service that you provide with the tools that you have. So if you're doing it with a drone, you want to be as fast as possible. You want to spend as little time touching the data while it's going through the system as possible. And I think that's important to note. Like you said, unlimited number of images, limiting the need to create subsets. The workstations that we're using are not, super powerful CAD workstations. They're just off the shelf, nice GPUs, something that you can get. So, keeping your costs down. You mentioned that we create improvements in the software every year. In this past year, we really, really sped up our DSM processing. And for anybody who doesn't know, creating the DSMs is probably, the largest time consumption in image-based photogrammetry workflow. So the fact that we knocked it down 10x really has improved our processing speeds over others out there. And then you also mentioned the script-based workflows. Somebody could literally code in a script as they're driving home from the site, offload the images onto a drive, and then just hit run on the script. In fact, they could batch process it. They could run it command line. So, for those people that are in a hurry, we give you all the options out there to get things done. As you mentioned, the automated scripts, what's another nice thing about them is they kind of make the software fail safe. If you're not a power user, you can just go in and set your key points in the automation. It will create the script and then it'll run it for you. So that's absolutely fantastic. So with that, I've created, and I did this in the past, and so we decided to do again, and I've created a couple of graphs based on processing speeds and times in comparison with the others out there. So At the bottom of the graph, you can see we've broken it down into 1,000 images, 2,000 images, 5,000 images, 10,000, and then 15,000 images. So we've got it set up that way. And then we put some costs to that. Going back to what we were talking about, costs. You've got a professional who's touching it. You've got a two-man survey crew that's touching this project, and then you've got a technician. You can put together costs for those, but the technician is the majority of the cost. So if we look at our processing speeds versus others, at 1,000 images, we're close, because other software can handle 1,000 images. That's not a problem. But when you get to 2,000, maybe that's where we start to see people breaking up their data sets. And again, if you break it up, you're adding 10 to 15, maybe 20% extra work, because you've got to have those overlapping photos, you've got to have overlapping control, you've got all kinds of things going on there. So take that to 5,000, to 10,000, to 15,000. Maybe at 5,000, it's not so bad. Maybe your client is more than happy and they're used to paying that kind of money and it's all good. But when you get to 10,000 and 15,000, you really start to see the inefficiency of breaking projects up into subsets. So if we look at correlated 3D and we say we're just going to process this in one data set, if we look at, again, just the amount of time people are touching it, I'm not saying, if it's 100 hours to process in the software, you could bill that 100 hours at, X dollars. You can't. So we're only looking at the amount of time that people touch it. And again, every time you create a subset, somebody's got to go back in and touch it. They've got to edit it. They've got to QC it. They've got to approve it to go back into the pipe and all that. So this graph is showing you potentially really your losses as you break those projects up into smaller subsets.
No, sorry, Eric. I was just going to say, I think this actually validates quite well, what we hear on the ground a lot, at trade shows, at conferences, when we get requests for information. Typically, people come to SimActive when they're having some issues processing. I'd say it's right about the 2,000 to 5,000 images like Mark. People are starting to see issues, spending too much time, indeed having to break up projects. And I would say that's really one of the number one, demand for customers, for users coming to SimActive is having to process, data sets, 1,000 plus images. So that really validates, your graph.
Yep.
Yeah.
And I want to step back just real quick because I thought about this, because we do also live in the medium and the large format world, and just as a comparison to people that are working in the drone space. I recently saw a county awarded aerial photography orthomosaics in Texas. It was something in the range of 9,000 square miles, and it ended up being about $65 a square mile. So that's not a lot of money, and it doesn't allow for much human interaction in your costing. So scale it up, consider that, be aware that anything you can do to minimize man hours on a project, to get to your results without that, is well worth it on the software side, to be competitive in this market, just to be competitive. And then the next slide I have, so we talked about what your costs are. Now let's actually talk about, how many hours your software is spending doing this. Again, we've talked about adding, 10 to 25% every time you subset a project, but it does the same thing to the hours in your project. For example, you can see on the right side of the scale, 1,000 images doesn't take but a couple hours for anybody to process. It's not much. But once we start talking about 2,000 and 5,000 on up, you really start to see a loss in efficiency in hours. So for example, this is no joke, correlator 3D, especially we get into large data sets with our DSM processing capabilities, we're clocking in at about 14 hours to do 15,000 images. So if we're 10x better than our competition, Now we're talking about 154 hours. So you're not billing that 154 hours, but it's still taking you 2 weeks to get your data set processed, whereas it's taking you overnight, in this instance. How important is that on your end when you're talking to potential clients, customers, about this?
But there's a lot of scenarios where faster turnarounds is ultimately happier clients and better decision making.
And it may be what gets you the award versus someone else. If you can turn it over in a week compared to your competitor who's going to take a month, that's a big deal. So I think there's certainly some real value in that. And again, part of this is due in part because earlier this year we released version 10, where our DSM processing speeds 10x faster than they were. So that really sped up the overall processing. The last thing I wanted to mention, which is the distributed processing. Fill people in a little bit on distributed processing.
Sure, absolutely. So distributed processing is, something we've worked on a couple of years ago. I think we released it last year. It is essentially, we offer the possibility to our users who have several licenses installed on several machines locally to automatically allocate and distribute the processing of a given data set. This is all done within the interface or without, even if you're scripting. And this is all done fully automatically, right? There's no tweaking through the interface or whatnot. It will automatically allocate all the project throughout all the PCs on a given network and use all that hardware to ultimately cut down the processing time even more. And so what we noticed is it's almost linear, that you'll get a reduction of time of almost 2x if you have 2 machines and 5x if you have 5 machines. So on top of being already a very fast solution, some of our users that are looking for even more power, even faster turnarounds, are turning to distributed processing, installing, creating projects that way, processing projects that way. And honestly, they are our power users, and they're having tremendous success with our software using that setup.
So we're going from, if it's 14, 15 hours to do 15,000 images without distributed processing, if you put 5 computers on it and they're running in parallel, you're probably going to knock that down to 5 hours. It's not real time, but it's pretty close. So, especially some of our bigger customers, bigger clients, where it's massive data sets and they need answers tomorrow and they need answers quickly. That capability is certainly there within SimActive. And from my view, what is the development team going to do next to refine this even more?
Yes, most definitely. We have very strong development team, very experienced developers that have a lot of experience with photogrammetry, computer vision specifically, and ultimately just making the software a lot faster. And quite frankly, quite honestly, like that distributed processing release was quite a shocker, but in a good way. Everyone was pleasantly surprised with it. Even our technical team, obviously they're the first to test the beta versions. We test the beta versions, and everyone can't really, believe their eyes. And then seeing the feedback from the users after in the real world is honestly quite rewarding for everyone here at the company and for the development team. So we're very happy, very lucky to have this group of individuals for sure.
Well, and you mentioned this too. It is truly a feedback loop.
Sure, most definitely.
Yep. Okay. Well, Michael, I appreciate your time. I know you're busy. For everybody that joined us in the webinar, if you left a question on the side, we'll get you an answer as soon as possible. We're dealing with a lot of buttons here as we do this, but this webinar will also be turned into a podcast. For those that want to listen to the podcast, it will be available along with this webinar. After this live, we'll have it available on our website as well. So, Michael, appreciate your time. Any parting words?
Yeah, thank you, Eric. I enjoyed it. Honestly, enjoyed it. I think it's an important topic. I was happy to participate today. And yeah, if anyone has any questions, we'll be happy to answer them. Absolutely.
All right. Well, okay. We'll sign off for there. And thank you very much. All right.
Cheers. Thank you.